Hi students, good morning. In our last class, we are completely learned about scattering factor or form factor. Why it is used? This scattering factor or form factor is used to determine the intensity of the diffracted ray when X-rays or electron beam are inciding on the crystal. After inciding on the crystal, the rays are diffracted. How much intensity is existed on the diffracted ray? So according to our data, according to crystal structure or waves or light, anything, the intensity value is always be proportional to square of the amplitude. On that way, two classes we are discussing completely form factor calculation. After calculation of form factor, that form factor value is directly proportional to intensity, and is for you can take the atoms are very minute insides. That form factor value is directly proportional to atomic number, which is equal to Z. On that way you can calculate the form factor value. After calculation of form factor value, that form factor value is directly proportional to intensity. I is proportional to F square. I is proportional to F square. So that is the measurement of intensity of the diffracted rays. That is also scattered amplitude. That is also equal to scattered amplitude. On that way, two main derivations are existing in that last two classes. Each and everything is calculated. After completion of form factor, that form factor value mainly calculated on Fourier analysis. In Fourier analysis, you can take the electron density rho of R. Electron density. Fourier analysis mainly based on the electron density in the crystal rho of R. Based on that way, you can calculate in the particularly form factor or scattering factor. Form factor or scattering factor. After completion of amplitude of scattering factor, the next topic going to reciprocal lattice. The next topic is reciprocal lattice. What is reciprocal lattice? In general way, this reciprocal lattice topic converted into two words. One is reciprocal, another one is lattice. So each and everyone knows lattice. What is lattice? Lattice is nothing but space lattice. Lattice is nothing but space lattice. Space lattice is existing with respect to three-dimensional point of view. That is lattice, nothing but space lattice. What is reciprocal? Each and everyone knows reciprocal is nothing but, suppose you have the number A. The number A reciprocal can be taken as 1 by A. This 1 by A term is called as reciprocal. The 1 by A term can be taken as reciprocal. So, according to the space lattice, we can explain the lattice is nothing but with respect to lattice points. With respect to lattice point. In three-dimensional point of view, with respect to x direction, y direction, z direction, you can representing the lattice points A, B, C. Those are the lattice points. You can take the reciprocal of these lattice points. Nothing but you can take 1 by A, 1 by B, 1 by C. These are called as reciprocal lattice. Particularly this reciprocal lattice already we can discuss in earlier classes. Particularly those are Miller indices. Miller indices. These Miller indices are indicated by letter HKL. So HKL are called as reciprocals of their lattice constant along the three directional axis, nothing but crystallographic axis. But Miller indices HK or L are smallest integers. Smallest integers. How the smallest integers are calculated? You can take the LCM of the denominator value. The LCM is multiplied with each reciprocal. You get the smallest integer. The smallest integer is represented in curved brackets. This is called as Miller. Suppose these Miller indices H, K, L are indicating in the square bracket. The square bracket indicating the direction of the planes. Direction of the planes. Square bracket indicates the direction, curved bracket indicates the Miller indices. So according to Miller index point of view, we can easily calculate the reciprocal lattice. So in our past class, this topic is also came. So according to Miller indices, they can give the planes, lattice planes indication by using Miller indices. Why? At this condition, we can again repeatedly explain the reciprocal lattice. Why you are explaining reciprocal lattice? That means here Miller indices are give the complete information about the lattice planes, not the particular lattice plane. Miller indices are not giving the full information, regarding one lattice plane, but it giving the information, about a set of family of lattice planes. So Miller indices are used to give the information about the set of family planes, not giving completely at one lattice plane. For a single lattice plane, they not giving the complete characteristics of the plane according to Miller. On that way, we are introducing reciprocal lattice. So based on Miller indices, you are not giving the complete information about the single plane. It gives the information about the family or set of family of planes. So at this condition, Miller indices and lattice constant point of view, we are failed to explain the lattice plane characteristics. On that way, we are completely introducing the next topic is called as reciprocal lattice. According to our crystal structure, every crystal consisting of two lattices. First one is crystal lattice. Second one is reciprocal lattice. So every crystal consisting of two lattices. One is crystal lattice, second one is reciprocal lattice. So every crystal there existing two lattices, crystal lattice and reciprocal lattice. You up to today or up to yesterday class on point of view, you are explaining about the only crystal lattice. But today class we are explaining about the reciprocal lattice. So this combination of crystal lattice and reciprocal lattice is nothing but a crystal structure. So every crystal or crystal structure consisting of two lattices. One is direct lattice, second one is reciprocal. Direct lattice is nothing but crystal lattice. Other name for crystal lattice can be taken as direct lattice also. So every crystal consisting of two lattices, one is direct lattice, second one is reciprocal lattice. What is a reciprocal lattice? First of all, just what is a reciprocal lattice? So according to our last class, completely that last class explaining about the Fourier analysis, Fourier transformations. Based on Fourier transformations, we can clearly explain about the amplitude scattering factor. So based on Fourier analysis, reciprocal lattice is nothing but reciprocal lattice is the lattice. Reciprocal lattice is the lattice in Fourier space in Fourier space associated. Fourier space associated with the crystal. With the crystal. So, reciprocal lattice mainly introducing with the help of Fourier transformation. According to our Fourier transformation, there exists in the Fourier space. In this space, the crystal lattice is existed. That lattice can be called as reciprocal lattice. So, reciprocal lattice must be explained with respect to Fourier space. With respect to Fourier space. This reciprocal lattice mainly explain the diffracted pattern of diffracted X-rays or electron beam X-rays or electron beam incident on the crystal. So, particularly this reciprocal lattice mainly explained about the diffracted pattern on the photographic plate. Diffracted pattern on the photographic plate, which is nothing but it is the map of this diffracted pattern is the map of the reciprocal lattice. Map of the reciprocal lattice. So, according to lay pattern or rotating crystal method or powder form method, any crystallographic method, each and every diffracted pattern is observed on the photographic plate like this. So, according to our lay pattern, the central magma is existed. On the central magma, there existing concentric fringes are formed. These concentric fringes or this lay pattern is mainly collection of reciprocal lattices. This diffraction pattern is the collection of reciprocal lattice. So, the diffraction pattern is created by using the reciprocal lattice. It is very useful to explain. This reciprocal lattice is identical with the K space, which is nothing but wave vector. Already known, K is equal to 2 pi by lambda, that is wave vector. So, this reciprocal lattice is always be identical with the K space in the crystal, K space of the crystal. Particularly that K space is nothing but which gives the wave vector. The diffracted waves or radiations, particularly which is in the form of wave. According to de Broglie analysis, every particle which obeys dual nature, one is particle nature, another one is wave nature. That diffracted rays may exist in the wave nature. That wave nature is explained with respect to reciprocal lattice. This reciprocal lattice is always be identical with the K space of the wave vector. Wave vector is nothing but K is equal to 2 pi by lambda. K is equal to 2 pi by lambda based on lambda is nothing but wavelength. So, reciprocal lattice always be identical with the K space of the wave vector. K space of the wave vector. This reciprocal lattice is represented. This reciprocal lattice is represented by using the letter capital G. By using the letter capital G. Reciprocal lattice. Reciprocal lattice is indicating by letter capital G. Reciprocal lattice is mainly representing by the letter capital G. Capital G. So, this capital G or sometimes some textbooks which is also represented by capital R bar. So lattice is nothing but in the form of vector. So reciprocal lattice is introduced by, is indicating by the letter capital G or capital R. This vector is constructed by set of this capital G, or reciprocal lattice is constructed by the Bravis lattices, constructed by the use of Bravis lattices. The collection of these vectors, the collection of these Bravis vectors, capital G bar, is satisfies the equation. That Bravis lattice of vector satisfies the equation is e power I into capital G bar dot R bar must be equal to 1. This is representing in Fourier transformation. Already I am showing in the past derivation. E power I into G bar dot R bar must be equal to 1. Particularly at this condition, according to Fourier transformation, this power G bar dot R bar value always be equal to 2 pi n. This G bar dot R bar value always be equal to 2 pi n. Here n is nothing but integer. N is nothing but a integer, which is at this condition that value is represented by, it is represented by k1 n1 plus k2 n2 plus k3 n3. In terms of k space, the reciprocal lattice vector can be represented by k1 n1 plus k2 n2 plus k3 n3. The reciprocal lattice G bar is represented as G bar is equal to k1 into b1 bar plus k2 into b2 bar plus k3 into b3 bar. With respect to three-dimensional point of view, reciprocal lattice is indicated by k1 b1 bar plus k2 b2 bar plus k3 b3 bar. Otherwise, sometimes it is represented by G bar is equal to kx bx bar plus ky by bar plus kz bz bar. Here k1, k2, k3 are integers. b1, b2, b3 are primitive lattices, otherwise which is also called as basis lattices. b1, b2, b3 are called as basis lattices. Sometimes we are bx, by, bz are the primitive lattices along the crystallographic axis x, y, z bar. So in this way we are representing the primitive lattices. This is representation of a reciprocal lattice. Capital G bar is equal to k1 b1 bar plus k2 b2 bar plus k3 b3 bar. So in this way we are representing these primitive lattices in generalized form according to the crystal lattices, that primitive lattices or primitive bases can be represented as b bar is equal to 2 pi into b bar is equal to 2 pi into or a2 bar cross a3 bar divided by a1 bar dot a2 bar cross A3 bar. This is generalized. So in generalized way I am representing B bar, otherwise B I bar is equal to 2 pi into AJ bar cross AK bar divided by AI bar dot AJ bar cross AK bar. This is the representation of primitive lattices in general way. This is representation of primitive lattices. That is, K is equal to 2 pi by lambda point of view in phase angle point of view. We can represent the basis vector, otherwise primitive lattices can be represented. In similar way, for 3-dimensional point of view, in 3-dimensional point of view, I am writing B1 bar, B2 bar, B3 bar. So B1 bar can be represented as 2 pi into A2 bar cross A3 bar divided by A1 bar dot A2 bar cross A3 bar. B2 bar can be represented as 2 pi into here 2. So A3 bar cross A1 bar divided by A1 bar dot A2 bar cross A3. B3 bar 2 pi into B1 2 pi into A1 bar cross A2 bar divided by A1 bar dot A1 bar dot A2 bar cross A3 bar. These are the primitive lattices, or these are the basis lattices representation along x-axis, along y-axis, along z-axis, along x-axis, y-axis and z-axis. So that is the representation of a primitive lattices according to your 3-dimensional point of view, x, y, z, b1 bar, b2 bar, b3 bar. So each and everyone knows the vector multiplication, cross product and dot product. According to your dot product point of view, I bar dot I bar is equal to 1, j bar dot j bar is equal to 1, k bar dot k bar is equal to 1. This is the dot product point of view. In the same dot product point of view, each and everyone knows I bar dot j bar is equal to 0, j bar dot k bar is equal to 0, k bar dot I bar is equal to 0. In this vector multiplication, totally two types. One is dot product, another one is cross product. Dot product is sometimes simply called as scalar product. Cross product simply called as vector product. This is the cross product. So this is the scalar product. Second one is the cross product or vector product. Vector product point of view, I bar cross j bar value is equal to k bar, cyclic point of view. Similar way, j bar cross I bar is equal to j bar cross k bar is equal to I bar, and k bar cross I bar is equal to j. Suppose this is cyclic way, you can take either clockwise or anti-clockwise. I am taking anti-clockwise. 3-dimensional vectors. One is I bar, second one is j bar, third one is k bar. Cyclic. I next j. These two cross product value gives the third vector. J continuation k, so I bar. K continuation I, continuation j. In opposite pattern, I bar cross k bar value is equal to minus j bar. J bar cross I bar. Actually, in the anti-clockwise direction, after j they are coming k bar, but j bar cross I bar is nothing but minus k bar. So k bar cross j bar is nothing but minus I bar. This is the cross product value. In other way, I bar cross I bar. I bar cross I bar value 0. J bar cross J bar value 0. K bar cross K bar value 0. Based on these vector multiplications, we are easily calculating the reciprocal lattices along the x direction, y direction, z direction. So, according to this relation, you get the exponential of I into E bar dot R bar value is equal to 1. On that relation, we can conclude some statements. We are conclude some statement. Those are according to the relation. First one, G bar dot R bar value is equal to 2 pi n. G bar dot R value is equal to 2 pi n. According to this relation, B bar J bar, otherwise delta I am taking, which is equal to 2 pi into delta ij. So in general form I am writing Bj bar dot Cj bar is equal to 2 pi into delta ij. Here delta ij value is equal to 1. If I must be equal to j, delta ij value is equal to 0 if I bar not equal to j bar. So this is the general condition for reciprocal lattice. G bar dot R bar must be equal to 2 pi n in general way. Bj bar dot Cj bar is equal to 2 pi into delta. Delta is nothing but phase angle. This phase angle is equal to 1, sometimes it is equal to 0. At what condition may be taken as 1 and may be taken as 0. So you can take it as 1 if I and j are both are equal. If they are not equal, it can be taken as 0. That is the first conclusion with respect to reciprocal lattice. And second one, the two lattices are related to above equation. So two lattices is nothing but one is direct lattice, second one is reciprocal lattice. Lattice and reciprocal lattice, these two are obeys the above equation. That is, above equation is nothing but G bar dot R bar value is equal to, always be equal to 2 pi n. So direct and reciprocal lattice must obey the relation, above relation, that is G bar dot R bar is equal to 2 pi n. And third one, in our crystallographic method, third method is rotating crystal method. What is rotating crystal? So the rotating crystal means which rotates, means it rotates both direct lattice and reciprocal lattice. So if the crystal is rotated, both the lattices are rotated. Not only single lattice is rotated, both the lattices are rotated. So crystal lattice is rotated. In a similar way, reciprocal lattice also rotated. So rotating crystal means it can rotate by two lattices, that is direct lattice and reciprocal lattice. And fourth one, dimensional formula for direct lattice is represented by length, direct lattice is nothing but L power 1. For reciprocal lattice, dimensional formula can be taken as 1 by L. So 1 by L dimensional formula can be taken as L power minus 1. So dimensional formula is L for direct lattice. For reciprocal lattice, the dimensional formula is L power minus 1. So this is the representation of reciprocal lattice. Why you need to take Reciprocal lattice. Nothing but why you are introducing reciprocal lattice. Why you are take or we need a reciprocal lattice. So, what is the main purpose of reciprocal lattice? This reciprocal lattice is introduced when Miller indices are failed. At what condition Miller indices are failed? Which gives the structure of the lattice plane, single lattice plane. But Miller indices give the complete information about the set of family of parallel planes. But it does not give the complete information about the single piece. On that way we are introducing reciprocal lattice. So this reciprocal lattice provides the geometrical structure. It provides the geometrical structure of basis of geometrical structures of basis for easily understanding, which gives the simple geometrical structures of the basis for easily understanding point of view. We are introducing the reciprocal lattice. On that way we can give which can give the complete information about the wave nature of the lattice, which gives the complete information about the wave nature of the lattice, which gives the complete information about the wave nature of the lattice. And the second one is which gives the complete wave nature of the lattice, which gives the geometric nature of lattice, nature of X-ray, otherwise electron beam, X-ray or electron beam diffracted pattern. On the main for these two uses you can introducing the reciprocal lattice. Reciprocal lattice which provides the simple geometrical structure of the complete basis easily understanding. For easily understanding we can providing the lattice, particularly reciprocal lattice. We have the reciprocal lattice, we can give the complete structure of the lattice plane. So on that way it gives the nature of the lattice. What the nature of the lattice in three-dimensional point of view, that provided by the reciprocal lattice. And once the X-rays or electron beams are diffracted, the diffracted pattern is existing of concentric circles or concentric fringes. The diffracted pattern is easily studied by using the reciprocal lattice. This is the main purpose to introducing the reciprocal lattice. So entire crystal structure they have the two lattices. One is direct or crystal lattice, second one is reciprocal lattice. Both having the equal importance. Some structures they are existing, the structure of simple cubic must be equal to structure of the simple cubic in reciprocal lattice. In crystal lattice point of view, the structure of the crystal is simple cubic. In reciprocal lattice point of view, the structure is also simple cubic. But at what the condition is changes, they have the lattice constant is A. Here they have the lattice constant is 2 pi by A. Some lattice constant values is changes, but structure is not changes for some structures. Particularly for BCC structure, the BCC structure of the reciprocal lattice is the lattices of the face-centered cubic structure. Reciprocal lattice of BCC structure is equal to lattices of the face-centered. Here the reciprocal lattice, here the lattices. Here BCC structure is equal to FCC structure in lattice of the face-centered. Those are can be derived in our next class. So this is the how the introduction of reciprocal lattice. This reciprocal lattice is mainly introducing at what condition we are introducing, particularly Miller indices are failed to explain the geometrical structure of the crystal and crystal planes. At that point of view, we are introducing the reciprocal lattice. This reciprocal lattice clearly explain about the or clearly gives the information about the lattices. Every crystal consisting of mainly two lattices. One is direct or crystal lattice, second one is reciprocal lattice. These two lattices have same importance. One is not, one is the large, one is the small. There is no large and small importance. They have the equal importance. So according to reciprocal lattice, simply is represented by capital G bar. Reciprocal lattice is represented by capital G bar. Here B is represented as basis primitives. Those are represented by, at what condition? The basis primitives B bar can be represented by 2 pi into A2 bar cross A3 bar divided by A1 bar dot A2 bar cross A3 bar. In this pattern, you can represent the basis primitives. Based on basis primitives, you can convert the or basis or lattice planes or lattice, reciprocal lattices for different structures you can be derived. Different structures for reciprocal lattice for simple cubic you can derive it, and face centered and body centered. In our next class, you can derive the reciprocal lattices of simple cubic structure, face centered cubic structure and body centered cubic structure. You can derive it. So in our next class, you can derive these reciprocal lattice for different structures. So today we are only introducing reciprocal lattice. Only we are introducing reciprocal lattice and their importance. Why you are introducing the reciprocal lattice? This is the main concept of reciprocal lattice in crystals, especially in our subject solid state physics. So this is the main importance. What is the main importance? Why we need to take the reciprocal lattice. This reciprocal lattice gives the simple geometrical structure of the basis for easily understanding. You can easily understanding the structure of the given structure by using the reciprocal lattice. By using this reciprocal lattice, which can give the complete wave nature of the lattice. Complete wave nature. Wave nature is nothing but that wave is existed in three-dimensional point. In three-dimensional point of view, you can give the complete structure of the crystal by using the reciprocal lattice. And one more is which gives the geometrical nature of the X-rays and electron beam of the diffracted rays. So you can study the crystal structure by following any one of the crystallographic methods. How many crystallographic methods are there? There are 4 methods are there. One is Ley method, second one is X-ray Bragg spectrometer, third method is rotating crystal method, and fourth method is powder photographic method. These 4 methods are used to study the crystals by using the pattern or diffracted pattern on the photographic plate. The diffracted pattern easily studied by using the reciprocal lattice. Easily studied by using the reciprocal lattice. That's why we are introducing the reciprocal lattice in solid state physics. This is the main importance of reciprocal lattice. The main importance of reciprocal lattice is easily understood the structures of the given structure or given crystal. The structure of the given structure in geometrical way. Geometrical is nothing but diagrammatic or graphical method point of view. You can easily understand. So the main purpose is wave nature to explain it, and third one is diffraction pattern is easily observed. This is the reciprocal lattice. So our next class we are discussing about the reciprocal lattice of simple cubic structure, face centered cubic structure and body centered cubic structure. So these 3 structures we are already discussed in past and earlier classes of solid state physics. So once you recall the structures, how many lattice points are there per unit cell, what is the structure, how the structure can be drawn with respect to lattice points and with respect to faces and lattice planes, those are ones you can check it once and draw it. After completion of this, we can go through the reciprocal lattice of different structures. Okay.